Hi, I'm Eric Lenask. We're here at this year's Telecom Exchange event in New York. On the show with me right now is Greg Weiner from Vertix. Greg, good morning. Thanks for joining me.
Good morning. Thanks for having me.
Maybe start me off with a little introduction to Vertix Consulting. Who are you? What do you do?
Sure. We're a small consulting firm, primarily focused on the telecom industry. Strong emphasis in wireless, but certainly everything around wireless as well. And as we all know, there's a lot of convergence between wireless and wireline, so we're doing a lot of work on the wireline side with cable companies, as well as a lot of the service providers to the wireless space, so companies like tower companies and deployment firms and the like. We provide a pretty broad array of consulting services, similar to that of a Deloitte or the other big 2, big 3, big 4 consulting firms. Obviously not anywhere near that scale, but a lot of our practitioners are former big 5 consulting resources. We do everything from procurement and sourcing work to IT outsourcing or on-outsourcing and bringing services back in-house, deployment program management, merger integration, acquisition due diligence, a pretty broad array of services across the telecom space. We're really industry experts and bring kind of deep experience within the industry to our clients.
Thanks, Greg. Now, you've recently put out a white paper talking about small cells and small cell deployment models. Talk a little bit about the vendor-carrier relationship that has to be in place in order to deploy small cells.
Sure. Well, I first start by saying that we just don't know how this shakes out. We've been talking for 5 years now about the hundreds of thousands of small cells that are going to be deployed every year, and it hasn't materialized. And part of that is technological. The devices, the units haven't quite evolved as quickly as many would have liked. They're not all multi-mode, maybe multi-user. They're not as small and easy to install as expected. But also the vendors and the carriers are still suffering from a macro site mindset, if you will. They approach these projects the same way they used to approach macro builds, and they're completely different projects. It's a highly fragmented landlord base. You have to look for opportunities to drive the scope down, and that's not in the DNA of a lot of these service providers. They're used to surveys and structural analyses and a lot of environmental work and construction work. Sometimes $80, $90, or $150,000 per site, and these have to drop by an order of magnitude. These have to be sub $10,000 deployments. So that's a completely different business model for the vendors. They have to get comfortable with a lot of small projects, which introduces a lot of deployment complexity, but also impacts their margins, how they resource, how they staff, and so on, and the systems and tools they use to support those projects. So it's a complete shift in mindset. And then on the carrier side, it's the same thing. They're not used to managing. Sure, they've got 40 or 50,000 cell sites across each of the major carriers, but half of those are with 3 landlords. So now they're talking about potentially hundreds of thousands of small cells across hundreds of thousands of landlords, and potentially hundreds of vendors deploying them. Operating in the power space on utility poles, cutting streets in the cities, things they've never had to do before. So it's a really significant shift in how we deploy and operate and maintain these. So I think what we're seeing is not a lack of desire on the carrier's part to move forward quickly, but really it's just part of an evolution. It's not going to happen overnight like everybody had expected.
Another tremendous area of importance, also media attention lately, of course, IoT and big data, and sort of how those two play in, and specifically how do you handle the onslaught of data. Talk a little bit about how small cells may be an answer.
Yeah, no, they definitely collide, right? Small cells are intended to not only provide capacity in places where carriers are capacity constrained. I mean, we're in downtown New York. This is a perfect example. It's really difficult to put macro sites that give you the capacity that you need. So it's a great area, a great candidate area for small cells. But small cells also allow you to get into buildings and penetrate every corner, stairwell, back room of every office building in the city. That's critically important for the Internet of Things. If you start looking at the types of things that can be connected, whether it's the basic things like thermostats and security cameras, cars, pretty much everything you can imagine can ultimately be connected, but you need coverage. It's not a capacity issue for those types of devices. They're going to tend to be fairly low bandwidth demands, but you have to have coverage everywhere. The small cells provide that ability, and hopefully someday provide that ability on a cost competitive basis. So you'll be able to drop these devices anywhere. You could put 4 of them in this building and hopefully do it with little to no cost. You just be able to plug it into the wall, get permission from the owner, and walk away. But today we're not there. Today you're signing lease agreements, you're securing backhaul, you're mounting to the wall. You've got some carriers that are looking at battery backup. It's just so much more complex. So this goes back to my earlier comments about shifting mindset. You really have to look at these differently. So small cells are an integral part of connecting the Internet of Things to the carrier networks. And I mean, clearly, wireline's not going to be, I mean, it's going to be part of the equation, but it's not going to be the last connection point for all these devices. These have to be really small, really cheap devices all over the place.
So taking out your crystal ball for a moment, you mentioned a number of we've talked about a number of important elements that are in focus right now. Where do you see the industry as a whole headed, and are there specific emerging technologies that you really see having a significant impact?
Significant. I think we're in an evolutionary phase more than a revolutionary phase. I mean, clearly, small cells, are going to provide an opportunity. Are going to open the door to all different types of connectivity than we had contemplated. But as a practical matter, I would say that for small cells to be deployed in the hundreds of thousands, we're talking several years, in the millions, even beyond that. You've got FirstNet, which is the government authority who's looking to build the public safety network. That could be a stimulant to deploying small cells all over the place because of their coverage requirements, the importance of having first responder coverage all throughout buildings. But I really do think we're in an evolutionary phase of wireless networking right now. 5G, lots of talk about 5G. It's several years out, still yet to be defined whether it's going to be a new era interface or what it's going to look like. But there's still a lot of runway for 4G technologies to evolve. And add capabilities. So I don't think there's anything shocking coming. Connected cars, I think, is an area of real interest. Not just with the basic things that you can do in interacting with your vehicle and manufacturers and dealing with service bolts and things like that with your vehicles, but also as you see what Google and others are doing with self-driving vehicles. Those are, getting the vehicles working is one thing and able to effectively drive on their own, but communicating with their surroundings and understanding the surroundings is where they hit the wireless networks. And that's going to be a critical component of any type of technology like that. So stay tuned. More exciting things to come, I'm sure.
Excellent, Greg. Certainly looking forward to it. Greg, thanks so much for joining me here today.
My pleasure. Thanks for having me.